All right, so we're loading in the STL file of the scan. We're going to explore reverse engineering it. I do want to mention that in terms of the way SpaceClaim does reverse engineering, as you saw, in our meeting a while back, there's multiple ways that this could be reverse engineered. Things could be extruded, revolved. You could start with a top-down approach and chisel out a block, or you could do a bottom-up approach and model each little piece. So
I think it's been a long time since we had that, but I think my recollection is that your preferred approach was sort of to look at it, recognize what the shapes were as a human, and then sort of create those kind of shapes. Like it looks like the front end of that thing is a cylinder, so you would try to model a cylinder of the right diameter.
Right, and in doing that, oftentimes whoever is going to be modeling this may have some knowledge based on how they expect it to be manufactured, used, etc., and that may drive it. Like if I'm expecting some two pieces to clamp around this, then having it be cylindrical is probably preferred. If this was going to be inserted into something, it might be beneficial for it to have a little bit of a taper or a draft on it. Or, if this piece is going to be machined, cylindrical is really good. If it's going to be cast and it's going to be, cast in a certain direction, you might need draft for the release from the mold. So, sometimes, having some knowledge and understanding of what the model is going to be used for and how it's going to be made, may draw different conclusions. But, like in looking at this part now, now that we have, the scan and just thinking of some different approaches to create this, like if let's say we're focusing on the initial shaft right here as a starting point. One could approach it from this view. I could, sketch out a circle and, have it be centered and then take that circle, and extrude it in this direction. And then when we get to, different areas, I could, do additional sketches or use some of, SpaceClaim's modeling tools, to create the geometry like in an extruded standpoint. So that's one direction we could go. And that's, a completely acceptable direction. Another direction we could head in would be, and so that last direction would be looking at cross sections here, because, you can see that as we go through the model in this direction, we can often see the diameters change and get bigger and smaller. And so, if we capture those as, circles in each direction at each size, that's one way to build up the model.
Right.
Or if we look at the model, say, in this orientation, if I were to, sketch out or extract curves or, you'll notice, in some areas, I may look at this and say, all right, I know it should be flat on the end. So that is, accurate. Or, maybe I look at the triangles and I think, all right, well, maybe that chamfer is actually supposed to extend all the way to the front face, because I know of, how it's going to be used in the assembly and, it should have a nice lead in all the way, or, whether there's rounds there.
I think I understand that. So what I'd like to do is have you, just do it the way you think that makes the most sense and just narrate what you're doing.
Perfect. Yeah, because on this model for this type of pin, Revolve is definitely the most direct and the easiest way to create something like this. Not all parts are revolved. So if we had a part that was not revolved, then I wouldn't, necessarily have the option to do this kind of method.
I mean, that's understood.
So, yeah. So on this model here, I would probably start by going into a cross section. Now you'll notice that let me go back here. The initial cross section we're in, happens to capture some holes, which, are not fully revolved around. So what's a good thing to do here is just take our, sketch grid and, find a nice cross section where, I'm capturing all of the detail that I want to revolve. And actually, I'm going to escape out of here for a second because, if we look at this area here, in revolving this, I'd probably revolve everything, but, not include these holes and then come in and make the holes, and that's
that makes sense. Yep.
On the top here, we have two options. We could either, revolve what is complete and then partially revolve, the other stuff, or what, might make more sense. And it kind of all depends on if we have, what kind of a pattern we have here. Sometimes it makes more sense to revolve the whole thing and then start making cuts. But if I look at it from this direction, it looks like this one, here, and this one here looks similar, but they definitely look different than this. This looks a little taller and narrower at the top. These two look like they are the same, but probably it looks like they're different from these. You could tell just by the rounds there. And then these two, also look unique there. So what I'm thinking from, and what is similar between them appears to be this this conical chamfer here.
Right.
So what I'm thinking would probably make the most sense is to revolve, say, this pin, just the kind of common part of the head here, and then we can come in and, add the tabs, semi-individually, just because they seem to be, there's definitely some similarities, but definitely some differences there. So, all right, let's do that. So let's grab and we are recording, just verifying that. So we'll grab our x-axis, go into a sketch, used a keyboard shortcut, and we'll just take that sketch and rotate it this way. And then, technically, we don't need a good profile on the top and the bottom. We really just need a good profile on the top to do our revolve. And so if I want to capture the part of the head, between these, I think the best place to do that is probably out like over here. So I'm going to try revolving around to here, and there we still have, so here, this is basically our profile. Now, if I zoom in here, some of the scan data is actually, pretty good and clean, and looks like we may have some good fitting to it. And of course, some of it is a little more jagged.
Yep.
One thing I want to do, I could either ignore the jaggedness and completely sketch it out on my own. However, if I don't have to do that, it would be kind of nice. So I'm just going to try something real quick. I'm going to make a copy. I'm just going to duplicate this body just so if, we'll basically have two here. So I can modify one and then still have the original. Because we have a smoothing tool that can basically, clean up a lot of that roughness there while trying to maintain the volume of the model. So in our facets tab, we have smooth, it's called volume aware, and we could just select the entire body from the tree. And if we zoom in to where it's pretty rough here, here I'm keeping a copy of the original, and I could actually have them shown at the same time. And in a cross section, we could see, if there's been too much deviation, it may make sense to work with the new model or just continue with the old one where, basically I can, easily sketch on the smooth parts, and then we'll just generate our own curves through the rough parts.
Okay. What's a rough size of the model that you're dealing with here?
The number of facets or the physical dimensions?
No, the number of facets.
We could check that in just a second.
Well, don't worry about it. It's just curious.
Sure. Yeah, there's a single button that you press and it'll tell you, so it's really quick to find out.
Is this a typical model size for what you deal with?
This looks very reasonable. I've received in 6 gig STLs that had 160 million triangles. Operations on that, depending on the operation, can take a while. So, that was, way too fine a resolution. So here where we have the smooth tool can often add facets, like if the model is too coarse. But there's also a reduce tool, and we reduced it by like 99.9%. And, you could still see the shape of the model, like the shape didn't change because a lot of those, it was just over mesh, so to speak.
Right.
So here is the result of that. Definitely got smoother in there. if we turn on the other body, so like, the speckle view that you see here between the two bodies is actually very good. It means that the two surfaces are very close to each other. If one was showing much more than another, it could indicate, there might have just been a lot of smoothing going on in that area. Here we could see it still looks pretty similar there. If I turn off the smooth one, we could probably ignore that stuff there. And then if we turn on the new one here, much easier to work with. Of course, that may not be the exact geometry we want, but I think it'll definitely help here a bit. And, what's nice about this kind of model, we're going to be creating cylinders, cones, spheres, tori, planes. If we need to tweak the dimensions after we create it, that's, very easy to do. So I think both of these will be good to work with here. So if we look at it now, it's not perfectly flat, but it's, a lot more, we could, reference it a lot more easily now. And then same thing over here, not a perfect round, but definitely a lot closer. So that's something that we could do. If we ever wanted to, say, 3D print the thing we scanned, this makes it, nicer there.
Sure.
So, now we could kind of get on with the creation here. And, one thing I want to mention, I'm just going to create a new design real quick. Traditionally, SpaceClaim, you model stuff up, you create as you go, but, there's no history, there's no, sketch parameters, everything is kind of, on the fly and direct. And, if this is, if we just want to create, a one-off model and not make any tweaks later, we could use this standard approach, which, I showed you the last time, but, just a quick recap here, in creating. If later on I wanted to change the size of this, I do have the ability to like add a dimension, like let's say across here, and if I want to go ahead and, move, these faces over, something like that, I could, do that and drive it, with this dimension here, like if it needed to be 60, something like that. So you can parameterize a model even with the more traditional modeling technique, but something new that, is often very useful with reverse engineering. We have this new process called block recording, which, if you're familiar with other CAD tools like SolidWorks or Pro-E or Inventor, it kind of makes SpaceClaim look like it has a feature tree, and we now have sketch parameters. So, let's say, for example, I model something up, and let's say I'll model something that's kind of revolved. So I'll put a rectangle there, and then, maybe like another piece here, and then we'll do like a piece, down to there. And so, let's say I dimension all of these things. I dimension from here to here, there, there. We'll dimension, the length of that. I could always do some trimming here to, get rid of extra pieces. Dimension, the full length of this, this radius, all these different things, and I can do this with the sketch here. So, oops, that's over. I double dimension that one. So, what this is, let's get rid of these two lines and make a nice clean intersection there. And, one more thing to mention is like this length here. So now this is a fully constrained sketch. I sketched it out roughly, and we'll take this into the STL in a second. Imagine I were to sketch this out on the STL, and I've got these dimensions that are close to the values I want, but, now that I look at it, I say, all right, this, maybe that should have been 4.5, and, the sketch solver solves for that. If this is supposed to be 65, it's hard to see because some of the changes are so small, but it's actually, moving those lines around, in a solving sense. And you'll notice that if I put too many dimensions on, if we over constrain it, it says, hey, this dimension is basically conflicting with taking this one and subtracting these two. So it Perfect. So highlights in red, and we can delete it and get rid of it. So
And you're showing me this because you're going to apply it to the model?
I'm going to apply it to the model, but this is something that is only applicable as of the current version released like a few months ago. So,
Okay.
if I showed reverse engineering demos for the last 10 years, it would involve something more like this, where you just sketch it out, you create it. You don't have, sketch constraints. But the one thing I actually haven't showed here yet is that when I finish creating this, all of those dimensions I saved are recorded as a history. So like, let's say I go ahead and, I revolve this around, that revolve is saved. If I then go and, let's say our next thing was to put in, a hole, based on where we think it is in the model. And, I set up a dimension, let's say from the hole to the front, and then the size of the hole. So, we create that there.
And
Each one of these steps.
That's all in your history.
Exactly.
Okay.
And this history has only been, added as a fully released feature in this version. So, it had been in the past, and so,
Well, the past is irrelevant to me because I'm only trying to show the Air Force how the present product can help them.
Perfect. So, and what's nice is, like I do things like I add chamfers, I add, maybe I put, rounds or chamfers, whatever, on holes, things like that, and then let's say I want to go back and change something at the beginning. Instead of having, like normally if I want to change, let's say where like this face is, I have to select it, I have to, pull on it, I have to set up a dimension, or I have to, do the same thing with this dimension tool here. But what this now allows me to do is, if I know the value that I want to change, if I know the dimension, I simply, update it in this panel, click play, and then, it repeats every action that happened after that, even when the actions happen on that face. And you now also have the ability to actually go back in, see the sketch, modify the sketch, play around with the dimensions, change the dimensioning scheme. So, this is kind of, what we see as the future of SpaceClaim modeling, because you still are direct editing. The tools are the same. You're still using, the unique tools that SpaceClaim has, but now, you have a nice clean history of the model, and, you can go back and easily change that.
Okay.
All right, so let me just close that out. Close this out. So I'm going to turn on the block recording here. We may run into a few, issues with it. There may be some things that either don't get fully recorded, or, we may have to, find a workaround for. That's kind of why I want to mention that, it's a newer feature.
Understood. Okay.
All right, so we got that on. I'm going to go back into our sketch mode here. And I could select that plane here. And we'll just rotate this around a little bit. We went down over there. All right, so we are in a good position. We've got our block recording on, and so by default, we have this fit curves option turned on, and this can be very useful, especially now that we have a nice clean scan here. What you're seeing is, a green line, a green sketch entity is a line. A blue one is a curve. So, we'll probably want to ignore some of the curves, and we can, we have two options. I can either select these and we have a project to sketch tool, or you can just do a simple copy and paste. So, one way or another, we're going to be going around selecting the ones that, look good, that makes sense. If there's an area where, there isn't one, then we could always just create that on our own later. Here we could see a little step in there, and that actually looks like, it's at a good angle. So I'll grab that and that. Here I have to decide, is it really two diameters? One thing I can do is I can adjust the tolerance on this curve fitting. So if I go ahead and I turn it up a little bit, you'll notice, it's a little more relaxed of a tolerance. Usually we'll get, longer lines in certain places, giving us kind of more of an indication. So yeah, I think it's, I think we're looking at it being just one here. And here I'm just holding down the control key as I select these. Looking at this hole, it's a bit different from one side to the other. This side of it actually looks a little bit cleaner. It looks like, there's kind of a bit of a ridge down in here. Now, one thing I know usually about scanning objects and line of sight and holes like this is that they can often be hard to pick up. Not sure if this
STL was not done through a scanner. It was actually came from a CT scan.
CT, got it. Yep. Okay.
Yep. But my guess is that that hole is axisymmetric.
Sure. And do you think the profile of it is something curved like this, or do you think it's something more conical and flat like this?
I mean, to me, the profile on the bottom looks more correct.
Yeah. Yeah. So what I think I'll do for now is actually ignore the hole. We could always, we may find that different cross sections are, better for one than the other. And right now, because I'm like working in this upper cross section and this one is down here, we could always just, do this as a second step and then subtract it from the model. So,
okay.
We can leave that as is. If we come up over here, yeah, so I know I want a vertical line, and none of these, I guess, none of these are really ideal for now. So I'll just leave that one alone. I'll grab that one. I'll grab this one. And I think that is good for there. So we'll take that. And I can either right click, copy and paste, or use that project to sketch tool. Either is acceptable. And then we'll see that if we hide the faceted body, these are the curves that we have so far. So we still have, we have some intersections we can make. We have some sketches that we still need to add. So we'll go ahead and just show that again. And I guess we could start from the end over here. So, a few things that I might want to, either look into or verify, is whether these, these lines are vertical or, off by a certain degree. Because, if this is at an angle, then we're going to get a cone out of it. If it's, perfectly horizontal, we'll get a cylinder. So, let's say we're going for a cylindrical shape. One thing I could do is set up a dimension to know real quick. So I could just dimension from this line down to here. And yeah, we're at a very small angle, so not even a degree. We do have the option to select that dimension, come over here, and change the number of decimal places. So here's something that is just happens to not, I could turn off block recording to measure this, to have it show properly. But as you saw here, changing that, property is just not something that's recorded at the moment. But
when you say block recording, what are you referring to? I'm confused about that.
Block recording is the history recording.
Oh, okay. Okay, so that's the history function. Okay.
Yeah, yeah. They decided to call it block recording because it kind of makes it in these different blocks.
Okay.
But one thing I could do here, I could use our measure tab and measure tool and just take a quick measurement across here. Rounding, it's still 0, but in this options panel, angle right there. So yeah, it's like, 0.003 out. So extremely close. If we don't address this, we will get a cone at a slight angle. And that is where the new sketch solver and sketch constraints comes into play. Because we essentially have a tool for that. So there is a horizontal constraint and a vertical constraint. We'll start with the horizontal. We may find that this model is actually rotated, 90 to the direction that we want. So if this flips 90 degrees, then we just want to use the vertical one instead. So I'll go ahead and click on it. So one thing I believe I need to, yep, I just got to turn, I need to remove that angle. That angle is fixing it to the 0.03 degrees. So, there's a couple ways I can delete this. I can simply select it and hit delete. But one way that I figured out why, I wasn't allowed to do this, if you click on the object and go to this drop-down menu, these show you all the constraints that are applied to that body. So here it's showing the dimension, and here it's showing this is actually going to affix it to this one. And so I want to use the vertical one instead. So I actually want to delete that one, and then I can delete that one there. So when you click on it, they simply delete it. So we really actually want to use the vertical constraint and click on there. And now you'll see that, it has that vertical constraint on it. So now that we have the vertical constraint on, if we're assuming that all of these are cylindrical and not conical, we could go ahead and click on each of these. Actually, I only need one of these lines. I think it just gave me two because it was a little curvy, but we're going to assume that, it looks like this is just one face going across. So we'll just use that one there. And let's go through. So this one will be vertical. Down here, where did I keep here? Oh, you know what? I still have this fit curves on, so it's still showing me these. So you can easily turn that off in the options panel here. Now it's a little clearer to see where I kept my sketch lines. So we'll make that one vertical. Oops, because I chose horizontal. We'll make that one vertical, and up over here. And those are all set. So now we'll make the ones 90 to that horizontal. There. I could always zoom out. This one. All right, so I believe we've gone and, wait, did I do that one? There we go. Yeah, so each one, so right now, by default, these little icons don't show, but we have this nice little constraint tips button that just shows you which ones have been added. So we could have a nice little visual check. So those are good. And now the next easiest thing is to, create my corners. Looking at this, it's hard to see, sometimes CT scan data, especially if we look at the other one, you get a lot of noise along the edges, and those spikes, may not really be real, and it may come to a corner and so forth. So,
yeah, I mean, I know from physically looking at the part that those spikes are artifacts of the CT.
Perfect. All right. So in our sketch group, we have different, sketch tools to create, and we'll use some of these lines in a minute. We also have sketch tools to trim up, modify. So here I can create a corner, just click towards the end of these and make that one. Over here, maybe I'll just start by doing these. It doesn't hurt. It'll be easy to sketch across there. We'll zoom out here. We want to go this side to that side, and this corner to that corner. That looks good. This one over to here. So I still have to sketch out some of those. I think it's we'll take a look and modify later. All right. So we've got all of our existing ones extended. Now we'll just go and sketch some lines. I could either, pick a point, or if I like it here, or maybe I want to go from like there to there, I could do something like that. And then it's just a matter of trimming. Now with the trim tool, if I click down here, it trims to that side. If I wanted to trim up here, then I click on there. So it's kind of gesture based on where you interact with the model. All right, so we did that line. Now we'll grab the line again. You know, and you know, I'm guessing that based on, you know, artifacts near edges, somewhere along here is a little more reliable. So, you know, I might just go up like this, just making sure I get that 0 value. That's all that's really important here. But again, I could, you know, set my horizontal constraint on it as well. So everything is easily adjustable here. Grab line, and you know, if I want to go quicker, L for line, you know, makes it definitely a lot quicker. Here, you know, again, I don't want it to be.
Excuse me. What did you say makes it quicker? I just didn't hear you.
Oh, sorry. Keyboard shortcuts. So you've got
okay.
L for line, C for circle, and they're customizable, so people can make them whatever they want.
Right.
All right. So we got 180 there, and yeah, we'll deal with that separately. And I'm just going to sketch a line across here. And then we'll create some corners like there to there, here to here, here to here. I've got one line to create up here. Again, you know, if I think things should be at a certain angle, you know, I could always sketch it like that, but you know, it seems like, you know, based on the design and the intent of this, that they're probably not at those angles.
Right.
So we'll trim that, make a corner here. All right, so I think we have a complete profile, and while I'm here, you know, the rounds we can either add at the sketch level or add at the 3D level. The main difference there is that, you know, when I exit out of this sketch, we're going to have one block with, you know, every single dimension in this sketch. If that includes the round, then, you know, that will be, you know, in that one block. If I instead leave these as sharp corners and, you know, do the block and then, you know, do the revolve, and then I come in and I pull these edges, you know, and make the rounds, then they'll appear as a separate block. So it's kind of half, you know, 6 of one, half a dozen of the other. It'll always be something you can modify. It'll just be listed out in a different step, whether we, you know, apply it at the sketch level or the 3D level. And both of those methods allow you to snap to the geometry. Like the pull tool allows you to snap the edge to the facets, and so do the sketch tools. So like if we want to do it from the sketch level, create rounded corner, you essentially just click on the corner you want to round, and then the round starts to follow you. And that little green dot is snapping it to the sketch here, you know, and I could always type in a value if I want to round it. Based on the number that we're seeing, I might be in the wrong unit system when I imported in the STL, because STLs don't have a unit system. So I don't want to, you know, interrupt this process, because we could scale it to size later on.
Sure.
Or you know, I could show you, you essentially go into file options, and under file options, STL. Yeah, so it's usually set to automatic and then it tries to figure it out, but you can always set it to something that you want. And I happen to have it set to millimeters, but you know, we could essentially just restart it, you know, in the right unit system, or you can scale it down afterwards. All right, so we'll add around there. I'll do a few at the sketch level, and I'll show a few at the 3D level. A lot of these look like they're intended to be sharp. This one here, I'm guessing, is round a little bit. That actually looks a little sharp. So I'll leave this one here and we'll round that in 3D. So if I'm just trying to make like a single off model, I don't care about precise dimensions or going back and editing it. I would essentially leave this as is. But if I want to be able to edit those dimensions, we just have to add them. You know, now that I've added the rounds here, that actually makes dimensioning just, you know, an extra click. Before adding the round, I could have dimensioned the whole length of the shaft just by this line here, but since it ends here, that's not really too useful. So, you know, it probably makes more sense to say dimension from you know, that line here over to, you know, the bottom of the head there. Oh, you know what? The sketches that I added, I have not fixed to horizontal, although I thought I sketched them out that way. So let's just verify that one there. And this one here. There. That already has one. That has one. Okay. I think we're good. This will be at an angle. So let's just grab our dimension tool again. Go from this line over. Okay, so actually I just clicked on this datum axis, which is not what I want. So let me just zoom in a little bit closer, grab that line here, zoom out, zoom in, grab that one. We'll go ahead and dimension that there. So we'll go through and just dimension either everything to fully constrain it or dimension what we care to change later on. You'll notice the dimension tool, you know, essentially updates to the type of measurement. So if I click on a line, it gives me the length. If I do 2 lines, it'll be either an angle or a length. So here we get the angle out of that. You know, maybe we want the length of that there and the depth of this here. Here's another good one. So yeah, if I don't put those rounds in, it's a little quicker to dimension because I'm essentially just clicking, you know, these
Sure.
single entities at a time. Grab an angle there. I'll probably have to put lengths and things in, but I'll just do some of these. Oops, undo that one. So you know, Windows shortcuts work. Like I did Control Z to undo that. Also, when you dimension, you know, I need to dimension between 2 points in order to get, you know, this corner to this wall. Where I place the dimension determines the orientation. So right now, my cursor is right between the 2 points, and it's giving me this aligned dimension at an angle. If I move my cursor up or down, it snaps to the horizontal dimension. And if I go off to the side, it gives me the vertical. So depending on which one of those I want, I just need to move my cursor around to get that there. So here we could do there. Actually, you know what? Let me do this first. I want to make this line coincident to our axis here, our sketch grid, which is also aligned to our world origin. That will make sure, you know, we're all on 0, 0, 0. So I will say that I want to do a coincident constraint between this line and that axis, and then that snaps down, and that's nice and blue. And then, you know, when I dimension, you know, different, you know, diameters, I could just go, you know, right down to this datum axis there and use that as my reference. So we'll see here that, you know, a number of these I can set up and constrain further by going down there. This one is constrained and this one is constrained because, oh no, you know what? So one thing I want to show here, which can be really useful, you know, lines can be constrained, the endpoints can be constrained. So for example, if I just switch to my select tool, I can drag on the model to, you know, see what is locked and, you know, what is not locked. So you know, here I could see that line is locked, you know, in its position from the axis, but it's not locked, you know, in its position in that direction, and its length, of course, is. So you know, this dragging can also often help, you know, figure out what's not fully constrained. Right here in this drop down, so we have the dimensions. That one's vertical there. All right, so we'll throw some more on for like this one down to here for that diameter. That looks good there. Here, I think we either need to give it a length of it actually, or what probably makes a little more sense or more, you know, dimensionable or quantifiable is this dimension, although that fully constrains it. I'll take off this angle here. Now let me just drag it. Okay, so so what I think I want to do, yep, I could dimension where this line is off all right, so here's what I could, or yeah, here's what we probably want to do. This face right here is, right along where this axis is. So it probably makes sense to constrain, that face to that axis. And then that, actually constrains this, because this is now constrained essentially to this axis. And now, we're all fixed up here. So, I could actually, if I wanted to, if an angle is more preferable here, I could go back to that angle, as that's usually a better way to adjust chamfers and lead-ins like that. So this is all looking good. Whoops, spun them all around. So I'm just gonna hit the left arrow to go back. All right, so I think the only thing, okay, so the back here that we need to do, not a problem. So say, for example, this diameter down to here, that size, and then this face, or this to there. And I could have even dimensioned that line. Both of those would have been great. So I think the only thing left are the radii, so the rounds. So we'll dimension those, one there, and one over here. All right, so we could just hide our scan just to double check. Everything appears to be dark blue, meaning it's fully constrained. All right, so we're looking good from there. If we wanted to make any adjustments now, we could. Like if I think it probably makes sense to round this off to a nice clean 60, I could do that. And, I could go through and essentially do this. Or I might want to, take a look at how it's modeled and make adjustments later. So, I could go through and edit them now or later. But let's go ahead and end this sketch and save the model, simply because we've done a good amount of work, and you never know. Let's move that period out of there. It's only taking a while to save because of the faceted bodies that are there. Those are the heavy ones.
Sure. Ethan, where are you based?
I'm in Massachusetts. Our office is based in Concord.
Oh, Concord's nice.
Yeah. Where are you located?
I'm in Guilford, Connecticut, just outside New Haven, but I went to school up in your area, so.
I grew up in Westport, and my mom is now moving out.
Moving out of Westport or moving up?
Yeah.
Oh, okay. Where's she moving?
Meriden, I believe.
Oh, okay.
Yep.
Westport's a nice town.
It is. Yeah, it was great growing up there, and nice school system. And my dad was an engineer at Norton Systems for 39 years before he passed.
No kidding.
Yeah.
I've actually done business with Norton. Used to be, I don't even know what it's called today. It's not Norton for sure. It's not part of UTC anymore.
Actually, right. It's gone. I think it it went to Lockheed, then I think it went to Northrop.
Yeah, it was part of Northrop Grumman. Yeah.
Yeah, he was there for a long time. And in fact, that job is the reason he met my mother, because he worked with her brother, my uncle, and he met at my cousin's bar mitzvah or something. So
no kidding. Okay.
I owe my existence to Norton.
Yep.
All right. So we completed this, and saved it, which is good. And here are all of those dimensions.
Right.
One thing that we're working on to make a little bit easier is the renaming of the dimensions and the, tying dimensions to the sketch, because, right here is not where you can currently change the names. If we were going to run like a simulation on this, which is one of the workflows, there's a button to create a parameter, and then it's down over here that you're able to edit, the name. But it shows up somewhere underneath here, and it's not very visible. So we have an active project going on to make updating these easier. There we go. But right now, usually the best way, if you have one sketch with a ton of dimensions and you want to edit them, usually the best thing to do is to go into the sketch and edit them from there. It's just a lot easier to know what's what in terms of updating.
Understood.
All right, so we've got this profile and we want to revolve it. So the pull tool does our revolving. The pull tool does our extruding if we just pull it in a direction. But we can either use one of these modifying buttons or the keyboard shortcut Alt to pick an axis. And in this case, the axis could be X. It could also be this edge because the edge is on X. So either of them are acceptable. And I can either hit Enter or click this play button or drag it around. And now we have that first body there. So, if we go ahead and take a look at the model, looks like we're looking, pretty good so far in terms of creating that. And from here, we'll kind of split the rest of the work up into kind of two areas. We'll do the head, and then we'll do the other holes and cuts over here. So this will probably take less time. So let's go and start with that. I want to make it a little easier to see the two bodies. So I can I've clicked on the CAD body, and from this little drop down, we could make it transparent. So now we can see in it a bit better here. So, I can see that this cutout here, goes through a couple different steps, which is fine. Here we have a couple holes. Also, one thing that'll make this easier to see, because I don't want it to highlight the face, in the display tab, you can control what's shown, and that includes the face highlight. So now I can actually hover over the model. I can still select things, and that's when it illuminates, but now I can hover over and not get really bright in our face here. So looking at the holes, I'm going to make an assumption that we just want one perfectly cylindrical through hole that goes through both of these at the same time. Looks like it's going right through the center. And nothing, nothing too, different or complex about it. So one thing that's really nice, I could always try to go into like a sketch across here and, sketch a circle and, pull it on through. But one thing that is very useful in reverse engineering with SpaceClaim is our cylinder tool. So I believe this will get recorded. We'll have to just verify that. But what you can do with the cylinder tool is select triangles, facets, and you can do that with a double click. And if I click the cylinder tool now, it would fit one to this. And so that, that's a completely different workflow where, I could fit one here, I could fit one to some of the inner ones and do some Booleans. But, you then get a lot of steps, and it's not always the most parameterizable thing. So I definitely want to highlight different, methods. So this method highlights sketching. Here, I'm going to double click and that grabs some facets. Then I can use this slider and grab some more facets. Now, if I drag it up too high, it'll select too many because it's essentially, it's changing the angle between the facets that'll select. So, I may want to grab some there, hold Control, double click over here, slide that up a little bit. Maybe I decide that I don't want to use, this data here. To fit with, and so maybe just those two areas look good there, and then maybe something similar here. It kind of looks good on the sides.
So when you hold Control, the orange facets that it's selecting are all on a common cylinder.
Right now they're just on a so the control, what the control is allowing me to do is add to my selection, like with each one of these groups.
Oh, okay. So you're selecting facets and then fitting a cylinder.
Exactly. Yep. I haven't fit the cylinder yet. I'm going to select facets and then fit the cylinder. Exactly.
Okay. All right.
And so, yeah, the holding Control allows me to add to my selection. Double clicking is what grabs it by angle. And then dragging this little slider up will expand and increase that angle to select more. And I think this looks pretty good as a starting point. We could always resize that cylinder if we want. but with those selected, I can just go and click on the cylinder tool, and that does get created, so that's nice. The only thing I'm concerned about is it says here selection none, which on replay, I'm not sure if that's going to be a problem or not. So, this may just be one of those tools that isn't fully recorded, but, everything we're doing here, could theoretically be done without block recording, and we could always dimension everything up, with the 3D dimensions. So, but it's good to try this out here. So we made the pin. Let's do this. If I hover over the pin and then scroll my wheel to this little axis, I could go into a cross section. So if I just kind of want to see what the fit looks like, I can also take our cross section here, and rotate it around. So those were just those areas that, didn't look like they were scanned too well, but, all in all, there's some. It looks like it may be off-centered a little bit. So I could just grab that solid body, and with the move tool, I could either, translate it around. Obviously I don't need to rotate it in this direction. And actually, let's just take a look at something. Let's do a quick measurement between the cylinder, the face, and the y-axis. Let me scroll and grab that axis there. So we'll measure between the axis and this axis. And so this is something that, was done in the background by SpaceClaim, because you could imagine that selecting a bunch of random facets and fitting a cylinder, that should have not been, perfectly parallel to Y. But in the background, if we find it's within a few degrees of an axis, we'll go ahead and shore that up and, make sure it's aligned and parallel. So that actually worked out really well. We don't have to make any adjustments on the alignment of this pin. What I could do, I guess the only other thing I want to check. All right, let's do this. Select these and do the measure again. Measure has an XYZ option. So it actually looks like it's not centered vertically. And here, I saw that, but I was like, are we sure? But yeah, because our scale is just a bit off, we are, we're not horizontally or vertically in this case aligned. We are aligned to Y, but that's something easy to fix as well. The move tool is a very, reliable tool here. So I could grab move, grab the solid body, and whenever I select a solid like this, the move tool automatically centers. So now I could just say move it in this direction, up to, and pick Y over here, and it just moved ever so much. Here it used an up to reference. So now if we go ahead and measure from here to here,
yep,
these zeros are what we're looking for. So now, it's nice and aligned. And what's nice is we could do it here to the pin before we subtract it out, or, we could do the same exact thing after we subtract it, 6 of one, half a dozen of the other. Now, if we look at this, just because of how it fit, it doesn't come to the end, fully. And to get it to subtract out, actually, you know what? I don't, we have two different tools to do a subtraction combined as a Boolean. If we want to use that, we need to make sure it extends all the way out. But we have a separate tool called split body, which will essentially take this face and extend the cut all the way out. So that's probably the easiest way to do that. So when we turn on split body, it's asking us for a target object. That's the body that we want to cut. Then it automatically moves to the next step, which asks us to select a face or another reference to cut with. And actually, let me just turn on face highlight so it looks a little better. So now it'll take this face and extend the cut all the way through. The one thing that's not automatic is the removal of, the pieces that got cut. If I go ahead and I hide the pin, there's still like a slug here and there. So I just click there, and that's the last step of the tool, click to remove. So I click there, and I click there, and now those have been removed. We could essentially exit out of the tool, and now we could, take a look and see how those are. So, if we still want to change the size or move it, the move tool, works the same way. I could grab these faces with the move tool, and essentially, if I wanted to move it, left or right, I could do that. Or I could dimension it. If I learn that this hole needs to be exactly 15,000 millimeters, 1.5 meters from here, I could type that. I can make these changes after the fact, and capture that here. So actually,
sure.
Let's say 14875, something rounded. So here, that actual dimension there gets captured. So if I want to change that later on, I could change that later on. And same thing right now, if we want to be able to easily change the size of the hole, you'll notice that, actually, I guess the create cylinder here, that has the radius. So honestly, if we wanted to change it, it'd probably be best to go back and change it here, because that's, where it was first recorded. So, so size and location easily captured there. Now let's go ahead and take a look at this area here, and let me go ahead and save this. As this is saving, I'm just going to load up a second SpaceClaim window because there's something I want to show you, because there's a couple approaches that we could take to doing these holes. And I just kind of want to show you what I'm thinking first.
Okay.
Actually, I think there's as this was loading, I think I just thought of another way that might be a little better and more in sync with what we're doing, but let me just show you the two thoughts that I had. So let me create a cylinder, an inner wall. All right, so the two options that we have that are pretty reliable. Let's say I put a sketch plane out here and I do a sketch out on it. So let's say like a rectangle there. If I just take this and do a cut with it, it just makes, straight walls, which our scan does not have straight walls. It's drafted, outward. Basically, these walls here are
they?
I believe so. Grab this face, X for cross section, move it, and then hide our solid.
Oh yeah.
Yeah, I don't think they're parallel.
No, they're not.
Yeah, and so
that's weird.
Actually, the way I was going to do this, I don't think will work exactly, because the way I was thinking of this, there's a way where if we basically project that rectangle onto this face, the walls it will make here are perpendicular to the face, which makes them a little bit drafted, but it looks like these may be at, kind of random angles. So, so all right, so like, so doing it like this, we get a straight cut. So if that's what we had, that would be the easiest way. But if I undo to here and I project this face onto the cylinder, and then I pull it in, you'll notice it automatically, drafts those in because these are perpendicular, to a tangent face there. So, if that angle is actually what it is on the other model, we're in good shape. But I don't think it is, because like,
It didn't look like it, to be honest.
because this looks, 90 degrees. Yeah, this is not. It would, be something like that. Okay, so
Yeah, I don't know what that angle is, but
yeah. Okay, so new game plan, which is actually going to be pretty easy here. These are at a weird angle, but I'm pretty sure that these walls here are just, parallel to these front faces.
yeah, I would think they looked that way.
Yep. All right, so let's do this. So, okay, let me undo, because as the block recording is on here, it's, recording each of the things. So I'll go back to where I want to be. So essentially what we'll do now is we'll just sketch a line across here, cap it off, and then cut either way with it. So this should be pretty easy to do. Grab our line tool, sketch it across here. I could, and I'll dimension it and, set up parameters. Usually this green dot shows up. Sometimes it doesn't for some reason, but here it's just snapping. I could snap it like that if I wanted, and then, maybe just a big hunkin line out here. And then we'll trim these up. All right, so we could dimension, say, actually, this line is kind of, the orientation is irrelevant, but it wouldn't hurt. It would make, I'm just trying to think if it would make constraining easier if it was like a line to this.
Yeah, I was going to say if you put that line through the center line of the cylinder, it might give you a good reference.
Like, you mean like snap it like the midpoint to there or something?
Something like that, yeah. Of course, you have to adjust your other lines, but
One thought I had, and I don't know if this will make it, if it will give us what I need, but if I make, if I constrain, let's say this one, that one, and then for now, just drag that up over there, drag this over here. Because now, maybe depending on what kind of references I need, if I dimension like here to here and, here to here, if I want to adjust these angles independently and off of, the center line, that might be the best way. Then let's just do that. I could always put some angles here, here. Oops, I constrained. What's the that length? All right, so I'll do that trick to drag it. The whole thing is not dimensioned that way. So I could say like this point, this axis. There we go. Okay, so that's good enough. And then, here I could either take this number and adjust it. One thing that, I've talked to development about adding is kind of like we have in SpaceClaim sliders, something you can drag like almost like a dial. So if I wanted to like, click it down until it fit better, I think that would be useful. But what I could do is I could delete this, then like, use my select tool, grab this point, drag it down, and here I can kind of see how the whole thing is updating, and actually I think I need to eliminate this dimension for a second so that I can drag this back up, and that looks really good. And if we go down here, we'll do the same thing. That's looking good there. Maybe set this to a nice clean 65. And then we'll just throw some dimensions back on over here. And maybe that should be 136. Here. And there we go. So, now we have our cutter specced out. If we need to make changes, we can easily do that later on. We'll end sketch. And, from here, we could kind of think about this in a couple ways. One thing I could have done, had I set up like a datum plane on this face, a datum plane on this face, and then sketched right down the center, we could do a symmetric cut where we, pull it in both directions. I wasn't thinking about that when I got here, and, doing that would add, steps to add the datums, etc. The option I have now is to simply make, a cut in one direction and then a cut in the other direction. Or I guess I could also move this body up to one of these faces, and that'll put it at, the 0 location, and then make one cut. Let's do that. So what I'll do is I'll move this here. So move tool, pick a direction, up to command. I can just go ahead and pick a facet over here, and it snaps it there. Now we do want to bring back the solid body that we're making. And now we're going to switch to pull. Because pull is pointing to the left, to the right means it's going to automatically cut. So I should just be able to say up to, and I'm going to scroll my mouse wheel to pick one of the facets here. And there it's made our cut. And just so we have a good look at the model, let's make it opaque. And so there's our cut. It's gone through the different, depths because we made it deep enough. And the one thing that it doesn't have are the rounds. So here's a great opportunity to show that. Looking at the rounds, this one, kind of looks the cleanest in terms of curvature and, non-jaggedness. So the reason I want to point that out is that is the first edge that I'm going to pick. The first edge that I pick if I'm pulling multiple edges at the same time is the reference edge. If I do like an up to, and this would have also been a good one to do, but I think the other one will be acceptable here. But when I pull multiple edges up to something, the first one is the reference edge. So we'll say we have those edges selected. We just say up to, pick a facet here. And now all of those are rounded, up to that. Of course, if I want to adjust this, what I think, what you should do is come in here and edit it in the block panel. If I actually edit it in the GUI, it will add another modification to it. So anytime you want to like tweak a value as a result of like a pull like this, you want to come in and do it in the block panel. All right. So that one's made. This other one.
So have similar cross section?
Yeah, pretty much. We could do one of two things. Either what we just did, and I would probably do something like, through here, then, move it up to this face, cut it down over to here, and then we would just essentially repeat that. I would put the cross section through here, create the sketch, move it to this face, and this part will already be open. So then we just make a cut into here, and the two cuts would, be one big pocket.
Yep.
So there is one thing that I want to show because, we could come back to that and it's kind of, just duplication. But, one thing that's interesting about SpaceClaim is if you have geometry that's similar, you can try to copy it. So the move tool can copy something like a hole. Let me do an easy one first. So if I just hold down the control key while I move it, it will while that's thinking, let me just show it on this one. So if I hold control while I move it, it makes a copy. It can, it can be, a simple hole, a complex hole. And then my thought is, after we have the copy made, we can just, adjust where that face is, adjust where that
Sure.
face is. This face can be, right now I'm pulling it so the angle remains the same because I'm just simply offsetting it. But if I actually wanted to further revolve it around, I could switch to revolve, pick this axis here, and revolve that and keep that angle. So, it would be equally as easy to either, oh, good, it did cut it. So, I think we could either, copy and adjust or, just sketch it out directly. Let's see. It looks like these faces are the same.
Mm-hmm.
These are obviously at a different depth.
Yeah, it's not clear to me if they're at the same or different angle.
Yeah. And I mean, we could always find out by putting in a plane through here, putting in a plane through here, and then measure them. Very close.
Yep.
I would think that.
Yeah, they look like that's close enough to be the same angle, I would think.
Yeah, and I would think even if we did a small rotation, they would be off by more than that. So honestly, I think we could do this. So let me undo creating those two datum planes. 1 and 2. Okay. So, if we thought these holes were different enough, we've seen how, we can create it based on this method here. But if they are if they are similar, I'm going to select it like that. If the move handle, doesn't show up in the right orientation, you can either use this direction button or the Alt key to alter the direction and pick on something like X or this cylinder, any of those. And let me first make this body transparent. So what I would like to do is grab this hole, with the move tool, and I'm going to put the move tool on its left face. And what you're able to do with this copy function is add up to it. So if you simply hold control while you do an up to and you pick a facet, it copies it up to that all in one shot. So I basically, picked a reference on the CAD body and then copied that to a reference on the scan body. So now if we hide the facets, so the one thing that gave it a little bit of a hiccup, you'll see how there's like a cutout here, like it's not fully through. What we ended up getting was a copy of that just turned into a surface. So let me see real quick if I could heal this up and make our cut. There we go. So here I'm just using the pull tool. The pull tool you can actually use to like extend the edges of surfaces. And now I should be able to do a Boolean, a combine, where this is the target, this whole surface body is the cutter, and then I can click on that piece to get rid of it. So, it kind of just threw the copy for a loop that there was this cutout here. It wasn't able to figure it out, but with a quick adjustment on the copy it made, we're able to then use that copy to subtract it out. So now we've got that and this. So we could just, we're deciding that it's parallel. So we'll say pull up to, pick a face down there like that. And, if we want to, since this was just copied off of this, if we go back and edit any of the dimensions on this one, those will get copied into this one. So if we want to, have this one have its own dimensions. What we could do is, pull this face, set up a dimension, to somewhere else, and then, here if I just edit the value of it, even by like, I should have done like 1550. That saves it as a easily editable dimension here. Interesting. So yeah, for some reason it's storing it as a change and not as that ruler, even though before it did. So I think that's something I just need to look into. But if we were to sketch it out and parameterize the sketch, then that is definitely the most direct way to be able to edit this. But this is a nice little shortcut if we're going to have similar things. So I could pull this one up to over here, and what I think I'll do here as a little trick here. So, I want to make a cut going across at this angle, and I'm not sure if that is, the same as any of our other ones. So what I'm going to do, the face that's here is just a flat planar face. So I could go ahead and just sketch a line across it, start over, we'll go like here to here, and just extend that out to the edge. Oops. So it's going all the way across. And when we now go back into 3D, that splits that face up. So just sketching across that face will split it up. And now I can just pull it back like we did before. But in this case, I'll then say, up to, and grab one of the facets there. And, here I want to make this edge round. I don't want to pick facets again, because, if this is a machine part, all of these corner rounds are essentially the same size based on the end mill. So, I just want to make sure they're the same. So I'll just say, pull that one up to, and I'll make sure that I scroll my wheel to pick the CAD face. And then those will be the same size. And this one looks like it had a sharp or, something like that. So now that that piece there is done. And actually, now that I look at these other holes, here's a really good application of the copy again, because, these holes, we've already taken the time to make sure that, they're aligned axially to Y and, centered to X here. So all we really need to do is move them and then, resize them. I could move it over and, eyeball it and to get it in there. Or let's just hide our CAD solid for a second. Should be able to speed that up a little bit. So here in the same way that we fit cylinders before, and actually, the same way we fit cylinders before, I'm going to select these facets, but this time I'm going to fit a datum axis. So in the same way you can fit a cylinder through some, a loop of, facets like this, you can also fit a datum axis. In doing that, it'll give us, that location. If I fit a cylinder there, we might still need to make some adjustments, but because I know that we've already made the adjustments here, what I could do is I can say that I want to take these with our move tool in this direction, and I want to do an up to, and if I just hold control while I go up to this axis, it'll only copy them in this direction. So there should be no movement in any other direction. And then once those are made, I could just resize them to the smaller hole size. I think it is just thinking, because it is not highlighting anything.
Yep, there's no hourglass or anything.
So yeah, sometimes, so there are operations that we expect to take a while, and so we give them an hourglass, and, there's some computation in the background. As you saw on like this model, the copying can, sometimes be instantaneous. So You know, it's just a tool that I think we intentionally didn't add one to because ideally it shouldn't take too long per se.
Right.
So, all right, so we moved it over. We can then switch to pull, grab our up to and pick a facet. And, you know, we could always, you know, down here, you know, capture that value there. So, all right, I think we are looking pretty good on the front here. And, you know, for all intents and purposes on the back, we're looking at, you know, some similar types of workflows. Like, you know, if we try to find some similarities between here, it's hard to say if this is one thing going around. But I think
A lot of those teeth have the same common outer radius, but not all of them.
yeah. And what's weird though is, you know, it's like a flat across it. You know, it's not.
No, it's not a radius. Yeah, it's a
Yeah.
flat.
So I'm not sure in this case if it would be worthwhile trying to revolve something because, you know, there may be certain parts that we could revolve, like maybe this like cut across here. But I'm
Yep.
thinking to make, you know, the shape of it, we kind of look at it from here, we take a cross section pretty close to here, and then we extrude, and then, you know, any of the faces that are similar, we might be able to cut together, but yeah, let's do that. All right, so what I'm going to do, this right here is a planar face, and I want to make sure that, you know, what we create is aligned to our body. So I'll select that as my starting point, go into sketch mode. You know, sketch mode down here isn't too, you know, useful because we're not making a good cut up there. So we'll use this move grid button, and puts the move handle on the grid, and we'll move it up to a nice clean cross section. And I think that looks pretty good. So I just want to make sure I'm not missing anything if I look from the bottom. One nice thing about cross-section view is it auto hides part of the model, which we can change, but I think that's pretty useful. All right. So first, let's see if I want to turn on the curve fitting, I just need to go into select tool, and then I can scroll down here and turn on fit curves. So what do we got here? There's a line. Some of these are looking pretty good and useful. All right, so I think this should be a good approach to start with. So we'll grab these. I'm just thinking about the intersection here of everything. I'm not sure our cylinder is quite big enough now, but I think that should be an easy adjustment. So basically, I'm going to ignore these rounds. I'm basically going to model the tabs without the rounds, and we'll add the rounds with the pull tool. The challenge with adding the rounds to the sketch level is dealing with like tangency things off of here. And if we just, you know, sketch this into the body, and, you know, pull and merge and then round the edges, I think that'll be the cleanest way to do it. So
Okay.
I think this one looks like a good line, even though it happens to be a little shorter. That one looks good. You know, this is indicating that this is a curved face, but, you know, if anything, it is barely curved. Well, I'll select this now just to use it. It's also indicating, you know, right now we're at the higher tolerance. Let me see what it says at the 10 here. So if I switch to 10, you know, here it's showing that as flat. The other ones, you know, it's showing a few more little pieces. I'm just trying to look at this. I want to see something real quick. If I'm going to take these two lines, copy and paste, and set up a dimension between them. All right, so that's only got 0.1. these two. I'm just curious if, if these are parallel or drafted at all. Copy, paste. Like half a degree. I'll do one more over here. Let's do that one. Half a degree. I'm going to make the assumption that these are supposed to be parallel. Of course, we could always dimension them, differently, but I'm going to go with that assumption. So,
okay.
Get rid of these for now. All right, so grab one of those. Grab that one. There and there. That one looks good. There's a good one. We already copied that one, and that one, and that one, but I haven't done this, or that. Ignore down there. Grab these here. Oh, already got that one. That one looks a little more horizontal. Plus, I'm going to make, I'm suspecting that each of these flat faces is, tangential to the circle at that point. So they'll get tweaked anyways a little bit. Got that one. These looks good. Over here, there. And last but not least. All right, copy and paste. What I might do, if this helps with some of the trimming or extending, I'm going to put like a circle, somewhere like in there. Now let's hide our facets. So we'll do some trimming from there to here, there. So that will, we added this ability to kind of do partial trimming, but I think it only, that's working pretty well. I think this will actually trim it complete. So what I might do is go through. I could just sketch more circles out of that. So let's just complete this one here. There. That one. Paste. Those. Copy paste. Extending the corners. Circle. Really don't know what these inner circles are, so I may just sketch a few here. I could also copy it onto my clipboard and just keep pasting it in when I need it. It's probably the easiest thing to do, but a few different options. So we could trim there, and then there to there, there. Let's see what our assets look like. All right, so there's a few places where I missed, so it's easy to come in, copy paste. Out. Rounds we'll do later. Copy paste. Here's one that looks like I'll probably sketch it. I could sketch from here. Something like that. And that. Corner there. Yep, here's a couple. Paste. Create the corners. Did I miss that one?
Looks like it.
Looks like it. 1, 2, 3, 4, 5. Copy paste. Intersections. Let's grab a circle for that one. All right, and I'm going to snap these to the same radii. It just got bigger. Let me see if I can just drag these. It's going to want me to constrain a bunch of things before I can edit those, but I think we're okay. I actually don't think any of them are intersecting, and maybe I'll should have done this from the get-go. Is just use the same size circle and trim. Honestly, I don't think I need to fully go through and do this. I'll just do this on this one that's sticking way out there. All right, so we could basically make all our little addition pieces like this. I'm not going to go through and dimension the whole thing. It's the same process that we took to dimension the rest of it.
Sure.
Just going to add some time here. So we'll go ahead and we're done with the sketch. And I'm going to save this. Now, if I do a normal save, it'll overwrite the file, which is sometimes what we want. But if I want to save kind of progression of the model, even though I have the tree here, if I go to save as and do save as new version, it makes a second file and adds a .2. The next time it adds a .3. So, this is more necessary when we didn't have this kind of history tree. But it could still be kind of useful if something, gets jacked up along the way, so to speak.
Mm-hmm.
All right, so it's taking a minute because of the facets.
While we're waiting here, my understanding is that this software is easier to use for reverse engineering than Geomagic, but perhaps has less functionality. Is that a fair assessment?
Yeah, my understanding, I haven't had the opportunity to use Geomagic, but we do have a lot of resellers that sell both Geomagic and our software.
Right.
And they say it takes longer to learn Geomagic. There's a lot more, functionality and features, for reverse engineering, and that, because it's not just like a general modeler on its own, you can't just like go in there and start throwing stuff together. You really have to like understand how to do it. It's kind of like comparing SpaceClaim to like, Creo or CATIA, where they can make much higher end models like Class A surfacing with like automotive things, and they have a true feature tree, and you can be very precise, but you really just can't jump in and start modeling stuff. So yeah, I think you're absolutely right about that.
So the learning curve is better here. So how long would you think it would take somebody in terms of hours of use to become, reasonably proficient?
So if they're doing reverse engineering over and over, and because there's different uses of SpaceClaim, but if they are doing this workflow over and over, I mean, let's say based on where we're at, reasonably finish this around, let's say, 5 at the end of the hour. We're getting pretty close. There's only a few things left. So, if someone were to do, say, 10 of these models, of maybe some are revolved, some are extruded, but something with comparable detail, but not super complicated. I
Right.
could see them getting extremely good and proficient with these kinds of models after, say, 5 or 10 of them. 10 of them.
Okay. 5 or 10 models that on average might be a 2 hour exercise each.
Yeah, I'd say that.
So 10 to 20 hours of use, and you'd get to a proficiency level. You wouldn't be a beginner, but you wouldn't be an expert either.
Exactly. Yeah. You may not be able to handle, some of the advanced modeling and some more organic type things or more complex things, but just by being able to revolve and extrude, which is pretty much all we've done so far, and threw in a couple extra things like the cylinder tool and being able to make copies, like the copy I made might have saved me some time, but if someone went through and just repeated the approach here, it might just take like a little longer, so but yeah, many models can be completed just by revolving and extruding, which
Oh,
is
sure.
pretty much what we're exploring right now. All right, so okay, so this is saved. Let me hide the scan actually. Okay, so we have these new faces here. One thing that may look a little strange, but it's kind of helpful for us right now, is that all of these new faces that we sketched out, even though they're not touching, are a single body. So I could just select them from here,
Right.
and it's pointing down to the bottom. And I know that, I believe they start at where this face is. So I'll just say up to and pick those, and then it'll pull those down. And, any of the interference on the inside is now eliminated. So nice, clean merges together. And if we show the faceted body, they essentially go all the way up to the top. So I could either just hide the facets for a second. There's now a few faces, but there is a trick to grabbing these. All of these are in the same plane. So there's the selection tab on the left. The first option up when I have this face selected is all coincident faces. So now they're all selected. And then if I show the facets here, I could do a pull up to and pick a point. This might be something that we wanted to mention, and so all of that is captured. I think that was captured within up to. But what I could do now is set up a ruler to the bottom. If I'm trying to round that off, let's say 32,400. That'll get saved down here to edit later. So this would be the kind of the first step, is to take all of these and extrude them up like that. And then looking around at them, it looks like there are well, see, it's hard to tell where the true common faces are, because it looks like this one and this one might be the same, but this one looks, it's higher up based on there. And it looks like it might just be the same as that piece there. Are they rounded? Yeah, they do look. Yep, they do look like they're round. So they're not. They're not just flat cuts. They do look like they are. So let's do this. We'll select that face. We'll go into a section. We'll move that section down to, let's say, here. Let's hide the CAD. It's round-ish, but let's do this. Let's do a circle from the center.
Yep.
Yep, that looks like it. Okay, all right, perfect. So this was not the sketch that I wanted to do for this, so I'm going to undo and go back out. The reason to undo here is it's, saving all the stuff I'm doing, so I just want to make sure that gets undone. So what I think we'll do, sorry, so this one, assumptions I'm making, this one and this one are cut the same way. This one and this one are cut the same way. Actually, this third one, and that's it. So this one, and that are the same. These two are the same. And then over here, these lower ones, right, it looks like this could extend right up to the top if we ignore that notch, and kind of looks like that's what, no, this face definitely looks bigger than, well, is it because of the chamfer on the bottom? Let's rotate it like this. Sometimes I actually just like to use the frame of the screen to help me with things. Like, so if I click on this button, I'm squared up to our XY. And then if I just bring this down here, if I put like, this edge right there, I can see that that's at a different height. So I'm just going to assume that these are different and we'll just cut them individually. So actually we could do it like, we'll do it like this. I'm going to grab these two faces that are, there's a weird, it's hard to tell exactly, because like here, I would say all of this is rounded. I'm not sure if this comes off at an angle like that.
Looks right. Well,
yeah, maybe it's just the noise there. All right. So, all right, for these three, this area looks the cleanest, due to, whatever is going along in that chamfer that got added there. So what I'm going to do is I'm going to grab these two faces and I'm going to go into a sketch. And very nicely, we have a fit line right here. So I'm going to grab that and copy and paste. And so we've got that. And I'm going to, I could snap it, I could sketch right along here, but I'm just going to like, overextend our cutter. This just, makes the cutting process more reliable, especially for changes down the line. And then we'll create an extension, a corner from here to there, and from here to there. Again, not going to dimension it. We always do that, or we know how to do that. So we've got that. I think that is all we need for now. So we'll go to pull. Pull brings us out a sketch just like the check mark does. And I'm going to take this piece here and all right, we're going to do a few things with this piece before we turn it into a solid. I am going to, so since, if this was just one cut all the way around, I would just say revolve, grab, our axis, make sure that cut is turned on. And if we want to see what that looks like, we could do it and see here. Hey, wait a second. It is the same cut. These are at different heights, which is why it looks different. So, yep.
Yeah, it looks pretty good.
It does. So these are the only two that are different, not a big deal, easy to address. And it's, in this case, it's even okay that this happened here. Let me try something now. I just try to pull this straight down. Yeah, let's just explore something a little different here. So pull this, and yeah, these two are different, right? Yep, okay. So we'll pull this up to here. That snaps like that. And then one way to deal with this edge, there's a few different ones. In the pull tool, you can, if I pull on an edge, we create a round. But the last option here is called pivot edge. I could either pivot the edge downward, which is not what we want, so I'm going to escape that. I could switch to this arrow here. Hold on, is it this one? Let me see if I could grab both of these and do it. Let me do one, but not the other. Let me see if we can move this edge. Translating it, not exactly what I want. Let's see if I can. The bottom edge of it.
Yeah, that's the problem.
Yeah. Can't tell if that's like a different circle there. This one, that one looks pretty good. Not sure if this face just needs to be like rotated a little bit, or if it's truly rounder than the other ones.
Yeah, it looks like it has a different radius.
Let me do this. Let's see if this works. Bend. Yeah, so this is actually an interesting tool that we have. It's called Bend. It's actually a sketch tool, but here I basically have a planar face perpendicular to a planar face, and it allows me to actually take that face and bend it. So unfortunately, that's not supported by block recording. The way we could deal, like if this was, supposed to be rounded, I could sketch like a 3-point arc, let's say, like across, like here. And then by sketching that from edge to edge, I get this new face, and I could always, strip that away and, then make, edits like that, kind of snap it there. So if it should be rounded like that, we could always, sketch that out and round it. The other thing is way back at, I think it was, at this sketch, right now where I recognize that, maybe something should have been curved instead of straight, I could go to the sketch here and edit the sketch.
Hello?
Yep, there we go. So I can edit the sketch, and here I could just go and sketch an arc instead of a straight line. But
right,
I already took the steps to fix it. So but that would have been the ideal way to do that. So let me just go back to where we are. Like that. So whenever you go in and out of a history, a sketch, you just need to replay it. The rest of the steps. All right, so we saw how we could adjust it. We'll just leave it for now. Let's Let me see if this one will adjust a little bit better. That one we might just need to do its own sketch for, but this one is flushed down to here. So that's an easy pull like that. Let's see if I can pivot this one. I'm guessing that probably the easiest thing is just to use our technique, although let me... Does this face look flat there, or do you think that's rounded too?
I think that looks flat.
Okay, so let me show a new technique that we can use for something like that. Anytime that we basically want to make a slice with a flat face, what I could do is, scroll through the model, double click on the faceted area, and just add a plane. That plane is going to be, fit through a sampling of all of those points.
Right.
Now I can take, sorry, my keyboard is just acting up. I don't know if it needs a new battery. 1 second. Just turn it off and on, see if that helps. Okay. Here I could use the split body tool. And if I zoom out, the one thing about this plane is it's actually cutting through multiple areas. So one theory is I could overcut it and then merge back the pieces I want. However, there's a quick, a slick option called local slicing. So with split body, you select the target object. That's the thing to cut. Then it asks you to select something like a plane to cut with. So we've got our plane right here. You click on the border. Now what it's doing is it's showing me all the areas that the plane intersects the model, and you just click on the one you want to only make the cut there. Apparently that's not supported by block recording yet. I'm guessing it's just the local slicing option. So we may need to overcut and merge back, which is okay. Yep. So here it's overcut, which is fine. 3 pieces. Click that one to delete. Now that we've got rid of what we want, but we want to merge the other ones back, I could just select a face on each of them, turn on combine, and that will automatically merge them, back to where we are here. So I think last but not least for this tab, we'll go actually. Here I could do the same thing. I could put in a plane to make this chamfer, but I'm pretty sure I could just grab, I'm guessing, these 2 edges, switch to chamfer. I'm going to pull to see. So yeah, that looks, I probably could do an up to as well. So up to, pick a facet, and that snaps like that. It looks like on the end here, maybe I shouldn't have picked that other edge, but here I think if I just pull that back, I'm just going to undo chamfer and see about just pulling this edge. I think we might just want to pull that one. So we just that one up to facet. There we go. That looks like what we want. We may have some rounded edges, which we could always kind of do as a group after. But, and it looks like there may have been a chamfer added in here, to make that geometry. And then we may just have some noise from the scan. That tab is needed. We could just continue to add geometry there, but we'd have to kind of figure out if that's noise or not. And then I think last but not least, on this tab, we go into this cross section. And we want to do a cut through here, that's going to conform to, the cylinder that we have. So I can do a project to sketch, and in this case, let's see, what will let me project? I'm going to project that edge. Actually, I guess it's really just a continuation of this edge down. So we'll just go ahead and sketch a line and go down like that, 180 here. I think this is supposed to be flat, so maybe we'll pick a point and go 90 there. Looks like there's a nice one here to copy and paste. And then I think if we just have something that, at least is at the top of there and comes down to say something over here, and then we make an intersection or a corner out of these. Oh, did I not copy that and paste that yet? Copy, paste, there it is. I think I might have clicked too quickly through that before. Trim there to there, there we go. Trim here, here. there to there, and there, there. So we're trying on pull. Grab that. Alt select our axis. Make sure we're on revolve. Oh, I didn't actually select there. So axis, we'll do a cut. Here we can pull in both sides, so a symmetric pull. And this is one where, we should just be able to drag and let go because it's not gonna, overcut into the cylinder because it's matched up to that cylinder there.
Right. So looks good.
This one, wait a minute. Did I undo too far back? I must have undone too far back at one point. That's okay. That, copy, paste. Something like that. And that one, or corner. And actually, so I sketched it in the middle and I don't want it to go all the way around. So I'll turn on my both sides, my cut, set it up as a revolve around X. And here I'm actually going to drag so that way I can stop it when it gets to these and doesn't, further cut. So that is the majority of those parts. If there's rounds and things, it looks like some of the edges, have, larger rounds, maybe chamfers. So, these two look like they have a chamfer. Switch to the chamfer option, pull it up to, grab that in there. The other ones look like they may just be kind of barely rounded, although that one looks like it's the same size. So I could pull that up to this other chamfer. So they're the same size. Oops, here's one more. Up to this one. One other option that I have in creating chamfers, it looks like something must have happened when my sketches didn't regenerate here. But with chamfers, you can change the selection. Like I kept adding them and they're showing up as different steps here, but I could always just go back to the initial chamfer, click on the selection icon, and then, just say, oh, these were actually supposed to be included too. And then, complete that. Of course, the chamfers after this will fail because I already created those. So, I'll X this out. So I just want to show that, if you kind of model it in the traditional direct modeling approach, you may get kind of redundant things. This will allow me to change these chamfers all individually. But, it would have been better to go back and change the selection if I do want them to be all the same here.
Mm-hmm.
Here, this is a chamfer that I think is at a non-standard angle. So one thing about chamfers, when you pull them, they do initially chamfer to 45, but after you let go of it, you could grab an arrow in a single direction and modify that. So here, if we're not quite sure what the chamfer angle is, we could go ahead and adjust it like that. And this would be as opposed to sketching a line and, revolving or making a cut like that. All right, so one of the last pieces at the top is this little ridge here. And we could probably approach this in a very similar manner by coming in to a cross section like this and creating our sketch. So this looks good here. I'm just going to assume that travels all the way down. So we'll copy and paste that one. it's hard to tell here what this inner surface is, because here it looks concave, there it looks convex. In some areas, it probably even looks flat. So I'm going to assume it's flat. We could always, we could either copy and paste these curves. We could, sketch, if it's a different round, we could sketch that out. But for now, we'll just go ahead and sketch some straight lines here. And create that. Copy and paste there. And just looking at how far it goes out, it looks like it goes a little bit past this, and that's something that I think might be easy to trim back later on. It doesn't go past the top, so I'm going to sketch something. It's definitely before this face, so I'm going to sketch something like around here. And trim that, and that. That, we could add rounds if we want, but we could also do that in 3D. So finish the sketch. Now, one thing I want to do here is I want to create this, but I don't want it to merge yet. So the Pull tool has an option called No Merge, which allows you to create it without it automatically merging. And so that will, I just want to modify it before merging it all together. So here, I might do the pull both sides, drag that along. It looks like it's going about there. So creates as a separate body. And actually, I created those as two separate ones there. And all I really want to do right now is adjust where this back face is. So it's really these two at the moment. And I could either drag or I could just do an up to and grab that facet in there. That looks good there. And see if we can merge these all together. So we'll grab face on each. 1, 2, 3, and try to combine. We got the one solid body. Let's go ahead, let's hide the facets. Let's make this opaque. So here is, the main shape of it. There are still a few, individual cuts, left to make. Like, this looks like it could just be a chamfer that we add. So like I could do, something similar to the other side, come in, whoops, that's a round. So escape out of that, make a chamfer, adjust it in one direction. Then I could always even just grab the face of it and pull up, making an adjustment like that. Change this transparent again. And then I think, the last big thing is there's like the channel in here. Or wait, is the channel at different depths or did I not? Yeah, okay, so I haven't cut the channel. I just sketched this out to add the rib. So, the next thing we would do, create a sketch for the channel, do a revolve cut. And it looks like there may just be, some other chamfers or other sketches to add. And then, once all of the main faces are there, it's a matter of if we want to break all of these edges into the small rounds, there's ways to, mass select edges. Double clicking will grab chains of edges. You could even, if we get to a point where, all of the edges in the model need to be, rounded, or all the edges in a certain area, you can actually set your selection filter to edges. So let me just hide the facets for a second. So like if I wanted to, like round all, say, like these vertical edges, when I do a box select, it selects either everything in the box if I drag from left to right. So I could, grab a bunch of edges and from left to right if they're in the box. If I drag from right to left, it's only ones the box touches. So one trick to grab all the vertical edges is you set the selection filter to edges, and then you go like right to left, across like a small area like that, and you tend to get, a number of those vertical edges. Now, you may find you still get some of the horizontal ones, but usually, a lot of times it's best to round the vertical ones first, because like you'll notice here, I want there to be, a nice round here so that the bottom loop is nice and tangent. So if I create these first, this way, and I could always, type in a number, I could snap them up to the scan, but when you round these vertical ones first, you then get, a nice loop of bottom edges, to round up like that. And, I think I might have just missed a couple weird ones at like an angle here, but, rounding is, usually the last step once all of the faces are made. But I do have a hard cutoff right now, but what do you think?
No, this looks great. I'm really appreciative. It's exactly what I wanted. So my question is, how do I access the step file, and how do I access the recording, your recording?
Sure. So once we finish the meeting, WebEx takes some time. With a multi-hour recording, it might not be done until tomorrow morning. Once I'll get an email, and then I'll forward that on to you. When you click on the link I send you, it'll be a streaming video, but at the top of the video, there is a download button. So you can download it. And let me save this as a SpaceClaim document. And what I'll do is I'll save this out to Step and send it over to you with the video.
Okay, that sounds fantastic.
Perfect.
Well, Ethan, I really appreciate your spending the time with me, especially on a Friday night. So thanks for your help. I'll talk with Dave about how this gets presented. Well, I have to edit this video way down because I probably don't have much more than 5 to 10 minutes of patience for it. So I'll try to hit the highlights and speak with Dave about if and how he wants to participate in the briefing to the Air Force. And we'll go from there.
Perfect. Sounds great.
All right. This has been fantastic. Now, I know Dave's the sales guy, but what is the rough cost of SpaceClaim per seat?
So licensing and everything has changed. I want to say it's around 5,000 now, and I believe that include they've bundled translators and things like that. I know there's discounting that can be done, and there's different options, like there's leases, there's subscriptions. I think the 5,000 is for like a full floating license. So if you don't need a floating license, I think I think the subscription or the named user is cheaper. If the Air Force is getting a bunch of these and they're sharing them, then floating is definitely more economical.
Right. And presumably, I think that SpaceClaim is substantially less expensive than GeoMagic.
Oh, yeah. GeoMagic is like 20,000, I think.
Yeah, right. Yeah. Well, this is fantastic. It's exactly what I'm looking for. So
perfect.
I appreciate your time and have a great weekend.
Thanks. You too, Dave. Have a great weekend, and definitely thanks for bringing this opportunity and interest to us, and look forward to sending it to you and hearing how it goes.
Sounds great. Thank you. Bye-bye.
Take care.